I think we've all wondered why the sky is blue, and while that question was answered many years ago by scientists, there is still a lot that we don't understand about the color blue. For example, if we look up at our sky and see a beautiful clear blue, it's because the atmosphere scatters blue light more than other colors. However, this phenomenon doesn't explain why the ocean is blue, or why some lakes are blue and others aren't, or even why Uranus is blue. In this video, we're going to try and answer just that. Why is Uranus pale blue? And while you're watching this video, if you like learning fun science facts like this one, remember to subscribe so that you can be notified as soon as we upload a new video. Now, let's get back to Uranus. As with so many things in space, Uranus's iconic pale blue color comes from the way that its atmosphere interacts with light. Its atmosphere contains a lot of methane gas, which absorbs red light very effectively. This means that when sunlight hits Uranus's atmosphere, most of the red light is absorbed by the methane before it reaches the planet's surface. Instead, the methane reflects blue and green light back into space, giving the planet its striking iconic color. This isn't dissimilar from how the sky on Earth also appears blue. And you might have noticed that another planet in the solar system also appears blue, Neptune. But despite both planets having methane in their atmospheres, Uranus's blue is notably different from Neptune's. Uranus's blue is far more muted than Neptune's and could even be described as greenish blue. So what causes this difference? Well, to answer this, let us take a step back and explain how we know what Uranus looks like in the first place. We learned a lot about Uranus during the Voyager flybys in the 1980s. During these flybys, the Voyager probes took images of Uranus at such a distance that it appeared no bigger than a coin in the sky. But despite the poor resolution, they did reveal something incredible. The images showed that Uranus had rings, and not only that, but they also revealed that these rings were opaque and miles wide. It was NT until 2014 that NASA launched a probe called Cassini to try and image Uranus in greater detail. It took Cassini over a year to reach Uranus, and for several months after its arrival, it performed what are known as low-altitude ring plane crossings, where the probe flies through the plane of the rings to capture images. Over time, it took thousands of images of the rings and the planet itself. These images were the highest resolution we'd seen of Uranus since the Voyager flybys. And for the first time, they allowed us to really study the planet's atmosphere. In one of the images, we could clearly see that Uranus had hazes in its atmosphere, meaning that there must have been particles suspended in the atmosphere scattering the light. But the particles were too small to be ice crystals, which left scientists puzzled. The only thing they could think of was methane. Since Uranus has so much methane in its atmosphere, this could explain why it was blue. But this still didn't explain why Neptune was a deeper blue. There was also another anomaly. In the same image, scientists noticed that some parts of Uranus were slightly darker than others. They weren't able to determine what this was at the time, but they were intrigued. To find out more, they decided to wait until the seasons changed on Uranus. When you think of Earth's seasons, you probably imagine warmer temperatures and longer days in the summer and colder temperatures and shorter days in the winter. But on Uranus, it's the opposite. Because Uranus is on its side relative to the Sun, half of the planet is always in daylight and half of it is always in darkness. When the northern hemisphere moves into daylight, it experiences winter, and when it moves into darkness, it experiences summer. On Uranus, summer lasts for 21 years and winter lasts for 21 years. So astronomers were prepared to wait a long time for the next set of images. But in 2018, they got lucky. An amateur astronomer discovered a storm in Uranus's southern hemisphere. The storm was massive, lasting for months and covering an area almost the size of Earth, But even better, it was big enough to obscure the planet's haze, allowing the team to get a glimpse of what lay beneath. And what they saw surprised them. They realized that underneath the haze, Uranus's atmosphere was actually a beautiful teal color. They needed to reach the conclusion that the hazes were actually made of methane. The methane absorbs red light, making the hazes appear blue against the backdrop of the teal atmosphere. But there was still something that didn't add up. The observations suggested that methane alone should make Uranus's atmosphere more of a teal color rather than the pale blue that we see. This led scientists to conclude that there must be another chemical in Uranus's atmosphere that was interacting with the methane to alter its color. Unfortunately, as of recording, they haven't been able to figure out what this chemical could be. Some hypothesize that it could be hydrogen sulfide, which is known to turn clouds a greenish blue. But this is just a hypothesis, and it's yet to be proven. So what does this mean for Neptune? Well, it seems likely that the same chemical process is responsible for the blue color of both Uranus and Neptune. But if this is true, then why is Neptune's blue so much deeper than Uranus's? Scientists have to hypotheses to explain this. Firstly, it could be that Neptune has more methane in its atmosphere than Uranus, causing it to absorb more red light and appear more blue. Secondly, it could be that the chemical that alters the color of the methane is more concentrated on Uranus than it is on Neptune. To test these hypotheses, scientists are looking forward to the results of the Neptune Odyssey, a mission that will launch in the mid-2030s. The spacecraft will conduct multiple flybys of Neptune and its moon, Triton, and will include a probe called the Neptune Infrared Spectrograph, which will help scientists analyze the composition of Neptune's atmosphere. While we may have come a long way in understanding why Uranus and Neptune are blue, there's still a lot that we don't know. Scientists are also puzzled by the fact that some stars appear blue, others appear red, and some appear white. Stars produce their own light, so their colors shouldn't be down to atmospheric gases like with Uranus and Neptune. For a long time, scientists thought that a star's color was related to its temperature. Stars range in temperature from around 2,000 kelvins to 30,000 kelvins, with our Sun being around 5,500 kelvins. But there is no simple relationship between temperature and color. For example, if this rule was true, then hotter stars would be violet rather than blue. Stars do emit light in a wide range of wavelengths, and at different stages in their lives, they can appear different colors, but they don't follow the same pattern. Some stars start off appearing red and then become blue as they approach the end of their lives, while others begin their lives appearing blue and end up red. Our Sun, for example, will end its life as a red giant. To complicate things further, there are stars that defy this pattern entirely. Scientists have recently discovered a star called KIC 8,462,852 that is orbiting in a binary system, meaning that it has a partner star that it revolves around. This star is cooler than its partner, yet it's emitting more blue light. What's more, scientists have discovered another star called HR 6819 that is orbiting a white dwarf. Despite being twice as hot as its partner, this star is emitting less blue light. As you can see, there is still a lot we don't understand about the color blue. As our technology improves and we discover more exoplanets, we lines learn more about the chemical processes that cause certain planets to be blue and others to be red or even green. But until then, the color blue will continue to be a source of wonder and inspiration for scientists and stargazers alike. And if you want to learn more about the universe, remember to subscribe so that you never miss an upload. Thanks for watching.